is like the fourth, like the fourth time. Okay, so this is the A1398 that came in before for no power, and the fix was we narrowed the issue down to the SMC. We reflowed the SMC, and the issue was resolved. Now the device came back in the same state, which was there was no charger communication. So the charger connected. And see guys, can see there is no LED on the charger. However, the difference this time, which I have noticed, is the issue. It's not the SMC, even though it presents itself in the same state. The issue it's not the SMC, and so just to check on the PPTC in voltage. Okay, let's switch it to 200 volt. Okay, now we're getting 15 volt, but something that has changed is initially we didn't have a short on PP3 before 2. Now we have a short on PP3 before 2, and now the ISL is heating up. So I'm just going to confirm that. So I will measure for short on the PP342 this inductor L1795. So we have a short. So that is going to be this component here. You can measure for that's L1795, and we confirm that we have, yeah, we have a short. So what you want to do, because the ISL is heating up, the ISL is 7100. E7100 here, because ISL is heating up, which is this. What we want to do is we want to remove the ISL and see if we still have a short. Okay, the ISL is out. So when you are replacing the like of an ISL chip, you have to be aware of its orientation. You will see where it says pin 1, for example. So make sure when you're orienting it, pin 1 will also go back as pin 1. And also when you flip the body side, so can I have a book? That one. I've got a pen. So underneath the chip, under the chip footprint, you should find something like this. So you find this, 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 and then on one side you get this, and then this. So the difference, so you see this, and this will all be the same, except here. Now that will tell you that that is pin 1. And also usually chip manufacturers will also put like a dot on, on the direction of pin 1. For example, come see the chip, come and see. So did you see that dot there?
Yeah.
Yeah, that's the direction of your pin 1. And then if you flip the chip on the other side, you say this side same, 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 except you see one side that will not be the same this side.
Okay, on the back. Okay.
No, not the back. See, you look here, look at this. Here.
Yeah.
Do you see it?
Sorry.
See, it has 4 sides. One of the side will have a small product like this. That is the direction of the pin 1. You don't see it.
I want to say yes.
Okay, come from. Don't worry about the pins. From here to here, you see how it is.
Yeah.
From here to here, you see how it is. From here to here, you see there's a small corner here, which is not the same as this.
Oh yeah. 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 Now I see. Yes.
You see it now.
Yes.
Okay. So that is the direction of your pin one, not on the pins here, no. So it's going to be on the middle pad. So, so you have to always be aware of the orientation of the chip, because if you put it back the wrong way, you may not only that the board is not going to work, you may potentially cause more damage to the board. So now let's see with ISL out of the board. Let's see if we still have a short on our PP3B42. Okay, now we still have a short on our PP3 before too. Now, I did tell the client to make sure they bring the charger they use on the device, because issues like this would most likely be as a result of a knockoff charger. So what we want to do is we want to remove our inductor, which is inductor for PP342 L79 1795, and then inject voltage on that line. Now the concept of injecting voltage on that line is whatever it is that is passing the voltage to ground will become either very warm or hot. Do you understand? So the concept is, if this is your PP342 line and then you have components connected to it. Now obviously, in order for this line to be complete, you need ground. So what we are experiencing now is a component on this line is basically creating a path to ground for PP, on PP342 rail. What we now want to find out is which components that are sitting on the line it's passing the power to ground. So if, let's say, one, two, three, four. So if this component is the component that has failed and is now allowing power to go to ground, when you inject voltage on the line, that component will become either very warm or hot, depending on how much voltage you push through the line. I don't know if you understand.
Yes. And what is the maximum we can use?
So usually when you are working on a particular, so what will allow you do allow you set the voltage? It's what is the rating of that particular line. In this case, is 3.4. So you just have to make sure that you do not exceed the rating of the line. So what you want to do now is you want to remove our inductor. So the way it's going to work, let us go to the schematic, and then I'll give you guys a better understanding. Um, okay, so the way this is going to work is this. Uh, this is our L1795, correct? So U1790, it's the PP3 V2 regulator IC. Now, from this point is where, so here, this is where PP340 gets generated and then sent out into the circuitry. So what we want to do, if you see, this is the main bridge between when it's been created and when it gets sent out. This is the inductor here. So what we want to do now is we want to remove this inductor. With this inductor removed, we now want to confirm if our short is on this side of the board or that side of the board. Now, after we've confirmed, most likely, oftentimes, it will be on this side of the board. Now, what we now want to do is we will now inject voltage from this point with the inductor out, and then regulate the voltage in a way so that we can see if, then from there we can now check out the component that will become warm or hot. I don't know if you guys understand.
Yes.
So I'm going to remove the inductor now. And by the way, the funny thing about this is, so sometimes your SMC can actually be the reason why your SMC can be shorted to ground. But usually when that happens, your ISL is not going to get, okay. So Usually, the way that will happen will be when you replace the SMC and it's not well replaced. If let's say you have a breach pad underneath the SMC, that's the way it will usually happen. So your SMC will just not die like that. However, we can take a gamble instead of removing the inductor, we can just remove the SMC. So we can do that, or we can inject voltage. Which one?
So you went for the SMC before in it where somehow maybe one pin is connected to ground.
So we
So
should remove the SMC first. Mm.
No, no, yeah. That will be that first because it's difficult. That is too many legs. It's more like a very difficult job when
No, it's not. It's not difficult.
no, but also you're the one who replaced the SMC, so I'm sure it's probably replaced. And why did that
No, we
say
didn't
replace.
replace the SMC.
okay, you did replace the
It
SMC.
was a reflow.
Oh, was the reflow.
Yeah.
But I want to see how you inject voltage into the I know it might be the SMC, but it is a way
To confirm if it's the SMC, is to inject
to
voltage.
remove to inject the voltage and remove that. In that time, it might not be the SMC, it might be the SMC.
Yeah, that's true. So Peter, what do you say? We remove the SMC?
And with these guys, let's do the induction. Let's inject the voltage.
Okay. It may be the SMC. Because if it is the SMC, and then it saves us all of the trouble of injecting voltage and
Because it makes sense when you say that maybe one of the pins is joined to the ground.
okay,
Which already give it a little bit of warmth.
let's just remove let's just remove the SMC. We can always replace it. It's not a problem. And another thing is because I also looked through the board, I don't see anything that could potentially be the reason why we have a short on the 5342 line. This is a gamble because it may not be the SMC.
No, it might be a game, but it might be the SMC, but it might not. What if it's just a cap, but it's not discolored, that you can see the name?
What is that?
What if it's a cap around?
It's a cap.
Yeah.
Yeah. So in this particular application, it's gonna be. Uh, I've already looked through the board, and there was no cap that stood out. So the SMC is out of the board. So the next thing we want to do is let's see if our shirt is Peter.
Let's see.
Okay, let's see. Let's just confirm. Okay, that's our ground. Okay, so Peter. Okay, so Peter was right. So it was indeed the SMC. So that saves us from removing the inductor and injecting voltage. And the build up to that was so the ISL, obviously, we saw that ISL was heating up, and the SMC, when this job came in before, the SMC was misbehaving, and we reflowed the SMC, it worked. And then it came back again. Now SMC,
Right.
so yeah, and yeah, but this is it. If you look underneath the pad, there's nothing that would suggest there's no breed underneath the pad.
No, I don't see any break.
Yeah,
So which means
SMC itself,
itself
it's an internal damage.
internal damage.
So yeah, so the next thing we want to do now is we want to replace the SMC, and yeah, and that's about it. What's the other? Okay.
So is there need for you to reball or you just lift it and transfer it without reball?
So I do manual reball. So I can manually reball the SMC, which is which would mean that I wouldn't have to actually use a stencil to reball it. That is one way, and the other way I can install it in a way that all of my parts are properly uh, communicating, and I don't have to worry about the state of having to reboot the SMC. So when I at first when I look through the board, especially the scenario at which it happened, how it happened, it's and also the SMC has also has the orientation. Also, we have you guys also have to be aware of that. So if you see here, you see the small dot here. Yeah, that is the pin one. So if you go to and but basically this is like a general thing with components. Manufacturers they tend to show you the orientation of a particular component. So if you zoom out, you will see that pin one is going to be here. So which means if I want to replace this chip now, I have to turn it this way because the pin one is this side.
So if you don't twist your body after you're taking it.
Yes.
No, 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 no. It doesn't matter how it is, provided this is on your pin one. You understand? So even if you flip it, you just know that if you flip it, then just flip your chip. You understand? Just make sure it's your because you know that if you zoom out, you know your pin one is this, the bottom. So even if you flip it, you still know where the pin one is. Yeah, so the confusion comes when you don't know, especially if you don't have the schematic and some of the chips the writer may be faded and you can't tell which is the pin one or not. And by the way, so the SMC it's compartmentalized. So a particular compartment inside the SMC might be giving you issues, and then the other will be just fine. And another giveaway also was the first time we started the video, our SMC communication at the charger level was fine because we got 20 volt. The second time we got 15 volt at PPTC in.
Yes. Yeah,
So SMC also has a way of SMC also has a way of playing a role in your PPTC in authentication in terms of not only the adapter sense now. Instead of you getting 15 volt, for example, which is kind of like the basic, especially if you're using an original charger, which is also why it's good to use an original charger. If you use a knockoff charger, come on, all of that don't apply. Just and puts whatever. So our SMC is out. So now let's. So there are two ways we can do this. Actually, there are multiple ways we can do this. So the pads, we can reuse these pads and reuse this pad, or we can reuse only one side pad. So which is remove all of this and only use this, or we can choose to remove all of that and use this. And another way we can do it, it's when you can remove this and then you use that only. But then instead of using this, after you remove this, you use the old one first.
all right.
It will give you a little bit of a grounding. Yeah. So you use that first, you remove it, and then you put that, and then it just flows. Because with this one, oftentimes what happens, especially if you're not able to control the heat and the airflow, you get that you either have a short or it's not properly installed.
So the movement when you take it off.
No, not taking no taking out. That's not really the concern. It's so when it's sitting back now, you just have to be careful that usually if it doesn't go well, you just have to all of that the procedure that you're avoiding eventually will be what you have to go through. In any case, so the one thing you can usually try to do is make sure you are a little bit far away at the very beginning, and make sure you have flux on your chip. Otherwise, the chip itself will absorb the heat directly, which may cause damage to the chip itself. But when you have flux on the chip, it makes it easier on the chip.
Yeah, similarly, because some boards are very delicate. Mm. Too much heat, phone will not come.
Okay, so the system or the method you use in installing your chip, your SMC chip, is the same method you use in installing your RAM chips. For example, if you're upgrading the RAM chips from say 16 gigs to 32 gigs, obviously you have to make sure you complete the process by tweaking the configuration because other than just the chipset itself, it has a configuration that you have to, which you can do at the resistor level. So the same method you use there is the same method you use when you're replacing the SMC. So now the SMC is replaced. The next thing we want to do is we want to give it a little bit of a cool. Uh, we to be safe, we will not replace put back the ISL, the old one. It's better we just put a new, not new, like a confirmed ISL that we can confirm that it's working. Yeah, because even if, for example, sometimes the chip may work temporarily, and then the client calls back and be like, "Oh, the machine died again," and then you have to go over the process again. So just to be safe, it's better to just replace SMC now. So uh, if the SMC is it's if the SMC is well replaced, first thing first, let's see if we don't have a short, because usually if you have a bad soldering, you will get a short on your PP342 as well. Okay, we don't have a short there. So now we do not need the ISL to get charger indication here. So we can, so once if our ISMC is fine at that level, with the charger, with our charger connected, we should get the green light in our charger. So what we want to do is just give it a little bit of time to cool off, and then we can confirm if we have. Let's see if we have charger communication. That was too quick. Let's just confirm something. I expect a slight delay. Okay. Yeah. Okay. Fine. We have communication. So that tells us that at least our SMC it's running. So the next thing we want to do now is we want to now put in a different ISL. Let's put a different ISL in place because we don't want to risk putting back the old ISL that was heating up.
It's something also you explained about
The
the
charger.
LED, yes.
Yeah.
So if it starts to show the amber light immediately goes green and goes amber again. What does that mean? You said something.
So I was. Are you talking about when I was trying to talk about charging, not charge? So I say for Maxif 2, when you connect, when it engages on the device, it has to engage with green, and then immediately goes to amber.
Yeah.
Now, but that doesn't necessarily mean that the device is charging, but it's just the state of the safe tools. That's how it's designed. So it's going to go from what is it called from green immediately to amber. However, two further states that needs to be understood. Now, when it moves from green to amber, and then from after that stage, the next phase of the charger, should it become amber after the first green to amber, it tells you that the battery is fully charged or battery is not charging. Now, if the battery is to not charge in the state of the light remaining green, it would mean that not only the battery will not charge, the SMC itself will be in reset state. Because with MagSafe tools, even when the battery is not charging, you will get a message to say battery not charging, but the charger itself will maintain its state of being amber. If the battery, unlike Safe One, the charger can will stay green when the battery is not charging. But Safe 2, it wouldn't necessarily. So Safe 2, the charger will stay amber, and at your operating system level to tell you plugged in, not charging. It will give you the reporting. Now, if the charger is to stay green and it's not that the battery is full and it's not charging the battery, the problem is not just going to be that it's not charging the battery. The problem is going to it will further mean that the state of SNC itself will be in reset state. You understand? Now, two ways you can easily adjust that. Two ways. Number one, it's first disconnect your battery. Try again. You understand? That's number one. Number two, disconnect your keyboard because your keyboard has the potential to basically pull down your SMC reset signal. The keyboard can do that. So after you disconnect the what is it called for MacBook Air, obviously because the keyboard communicates through the trackpad cable. Once you disconnect the trackpad cable, obviously the communication as what has been broken. So then it should work. And then if it then doesn't work, now if it doesn't work, how do you troubleshoot a scenario like that? It's the same thing that we had on these 15 inches. What you need to do is you need to find out if SMC reset L signal is low. You need to find that out first. Now, if SMC reset signal is not low, then you know that you are gradually moving towards the SMC itself. Because before you get to the SMC, if the signal is low, it means the signal may can also be pulled down by the SMC itself. Yes, but in this particular case, before you go to the SMC, find out if the SMC is being asked to remain in that state, which is go to say for example now. So let's go to U 5000 is the SMC. Now at U 5000, let's go to our U 7100. U 7100, you see we have here R7100 says you have SMC reset L, which is gonna come from which is gonna come from which is going to be basically controlled by U 5110. Now, this is a chip that will basically can cause the SMC to go reset state. So now, what you want to do is you want to see if you have SM if this signal here is low. What you're supposed to get is 3.4 volt. If you get anything lower than 3.4 volt, if you get anything lower than 3.4 volt now you cannot blame the SMC directly. Why? Because you are having lower than 3.4 volt. Now, what you want to do now is there is a resistor here. This resistor has communication with the charger. So what it says is charger reset L. Yeah. Now what you want to do is you want to sever the communication between this point and that point. Remove R7100 and see if you have high voltage here or high voltage here. So the point is the way you narrow it down is first of all make sure that the SMC is not being asked to remain in that state. If that has been confirmed that you have 3.3 volt here, now you're gradually moving towards the SMC because if the SMC is not being asked to remain low, now the only component that will be able to go in that state or remain in that state is the SMC itself because the SMC is not being it's just like an enabled signal. So if it's not being asked to be low, then the SMC itself it's not something you have to look at, which is exactly what for this machine, which is exactly what happened yesterday. So we checked, there was no SMC reset L. The SMC reset L was not big, it was perfectly in place. And then we went to basically that was why we had to go reload the SMC, and then it temporarily worked yesterday. And then today the SMC came back dead. So and then in terms of so usually one of the reasons why I always advised not to delve into how it happened is because right now I cannot accurately tell what got affected first, if it was the ISL
Or the
or the SMC, and how it happened. You understand? But I'm not really interested in how. I'm just interested in getting it fixed. So it's important that you are able to analyze or go through your schematic in a way that it should make sense to you. Because once it makes sense to you, you will be trending in the right direction. If not, you just be doing whatever. You just do here, do. And usually when you do that, that is why when the machine comes from a person, usually they will say in the repair industry, they will say that the harm a technician will do is way greater than the harm somebody like who has no idea about repairs will do. Because somebody who has no idea, there's this there's this level of um, caution they take. Ish, I don't want to. But a technician who think is a technician, bruh, he's gonna everything, everything,
You're gonna move all the chess pieces
bruh. I tell you, you remember back in the days when we used to have the issue of GPU on 2011 machines. Where you okay before then, back in the Windows days, AMDs, back in the Windows days, back in the good old days, the DV 9000, the DV, the
HP one.
yeah, the HPs, like back in the days where uh, you oftentimes the common thing that fails on those is the GP, just and then yeah, it starts working again. So that was carried over to the 2011 15 inches GPU. But then that same state of behavior was materialized in 2012 15 inches A1398, and people still had that carryover of GPU. But in this case, it was not the GPU. It was U8900 that was, which is basically the same circuitry of the GPU, but not directly the GPU itself. So it's just the thing with when you are used to this is like, yeah, if I did it here,
Next thing
it
I
should
did,
also be, yeah. Sometimes you can get very comfortable that you just assume age, which is why I find it very difficult when somebody say to me how to fix a particular, and if repairs was straightforward, no power has one method across all devices, then you can show me how to fix no power because I can use the same method on my device. But in this case, no power is a mere description of varieties of problems that will seemingly cause your device not to turn on. So if you just tell me how to fix no power, and then I apply your method on how I fix my no, but that is, you understand. So, for example, you watch YouTube on how to fix no power, like yeah, and there has to be
go on the second you test it, you see the readings are okay. So what is wrong?
yeah,
Now
like
you know where to go because
yeah,
you just know one thing.
which is why then the how to's it's good for kids, show kids how to get them excited. But somebody who has work to do, how to, you have 50 100 machines to work on. You watch one how to, and then what happens to the rest? And then the mentality is, the funny thing about this repair of ours, you can be tricked into having how to can work for you 10 out of 10 machines. You can use how to fix 8, and then the next time you wear your technician badge, now we have them all covered. And then when they start coming, you just start applying the same method and just start killing them and telling the guy replace board, tell them this is faulty, that is faulty. My friend, how is it that every board that comes, it has one fault in your own assessment? And when they tell you replace power management, I have a friend who always tell me power management, power management. My friend, what is with you on power management? Any machine that doesn't power on power and management IC, he will call me. Do you have power management IC for so and so machine? What is the state of the machine? No power. I know it's power management. My friend, what are you talking about? No power. I know is what your board is. It has goes through a complex design. It's not just one component that is power. That's not how it works. But
That's
yeah,
what they refer to. I work in a retail industry, phones and stuff. Anything dead, power management.
yeah.
anything not charging is power management.
Yes,
So
it is.
anything without a backlight, as long as you don't see anything on the screen, it's power management. So you have to narrow down everything. Like when you get it, you have to know the state of the device. Then you start from. Because if you listen to clients troubleshooting, then you'll be confused. You follow that.
Yeah, but also the clients themselves, you don't blame them. There are two layers to every problem. The perspective of the user and the state of the device, they are not the same thing. The client comes to tell you my machine is not charging. Yeah, that is their own description. But the state of the device may or may not be exactly the description. Why is it not charging? So if you now come, oh yeah, charging IC, and then you just go, you won't charging IC. If it doesn't work, then you
So
have to
instead,
replace.
instead of how, you have to ask yourself why.
And then from there, you follow the
Yes,
basic
you
check.
follow the basic thing. Why depends when you ask yourself, not how. Oh, how it's going to be something else.
But you can get clients. I'll tell you, I know.
100%. Yeah, 100%. I know what is wrong.
I'm sure.
I know that is easy to.
Okay, so that iPad man, the friend was telling me that the screen is broken.
Then when you go to someone who's not on it, he's going to charge you for speed.
Yeah,
They'll
and
charge that.
it's almost became a problem because I wanted to see the guy. The screen is not broken. Like I can see. It's like the screen is broken, my friend. Just take it, go and check it. I said, okay.
No, you don't argue. You just
I
take
said, okay,
whatever
it's
they
fine,
do.
yeah.
When you do your own assessment, you tell them that this is what I find out. Because you can spend the whole day trying to tell them this is not broken. But you
Yeah,
tell
I
them
saw
it's
I saw there was going to be a problem there. There's an issue. We're going to
Issue.
find. I said, it's fine. Okay, just give me the device. I'll see. I'll check it out.
But there's also another component to that. So, come on, let me just finish here.
this is the right thing.
So there's also another component to that. You do not disregard completely what the client has said, by the way. You don't argue with them, you don't disregard what they have said. You need to understand what their problem is because that is going to help you build your starting blocks. I mean, that will help you to have a beginning. So sometimes because it doesn't even make sense for you to argue with the client when you yourself have not confirmed what the state is. For example, the client said, I know it's a no backlight. And I know, but when they tell you I know it's a backlight IC, what they don't understand is the backlight IC doesn't operate alone. There are many ifs and before the backlight IC will actually work. So before you argue, I got a client who brought a 16 inches in, and then he said, I know the problem is the battery. It's a no power, but he said, I know the problem is the battery. Obviously, you don't argue, you check it out. But it was so funny that the machine didn't start um, with in that state, which I had to run DFU on the machine before we start. But then even after that, obviously, because the battery cells were swollen, I still had to replace the battery. My point is you don't disregard what the client has said. Work with what they say. Only when they tell you what to do, then that then becomes a problem. Because if you tell me, I know the problem is the power management chip, or I know the problem is the pattern IC, replace the pattern IC. So what we tell them is, it's fine, we replace the pattern IC. However, if it doesn't resolve the problem, you have to pay for that.
Yeah.
Yeah, you have to pay for that service of the backlight IC being replaced, and then pay for the no backlight.
We know that company with proper diagnosis.
So maybe that way that may kind of allow them to say, yeah, it's fine, just do your thing, just yes.
So you
So
say if they tell you to replace something, you replace it, you charge them.
no, that's how it is. So we tell them from the front, they tell you, no, 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 no. I know, okay, it's fine. I'm gonna replace it. I'm just gonna charge you for that service. Now, what you both of you are doing is you are now separate. So you have successfully separated the problem. You say it's not charging. Yes, it's fine. I'll replace the charging IC for you. You understand? You have separated yourself from the device not charging now. You are only billing him. $250 for just there for the cheap. No, 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 I know, replace it. But then it's also a gamble for you because sometimes they can also be right. Just like the same guy who how to has been helping him for 9 out of 10 machines, and then he feels like, "H man," they start making calls, bruh. If you have any repair, bring it here. So let's just see if we still have our charger communication, and from there let's see. So if our PP bus, if our ISL is properly replaced and our ISL is functioning, we should have our PP bus voltage. Okay, so we have charger communication. The next thing we want to do is let's see if we have PP3 V4 too. We should have PP3 V4 too, because with the even with without the ISL, we should have PP3 V4 too. So let's just say let's just that's not good. 4 point, that's not good. Let's see what we have on our PP bus. Okay, that's fine. That is fine. SMC is doing what it should do, but let's see what we have on our PP bus. 12.5. Okay, that's okay. Yeah, that's pretty much 12.5. Okay, at 12.5, we should be in SO. Okay, let's see if our fan is spinning at 12.5. That's close to what we're expecting on PP bus. Yeah. Want to see if our fan is spinning. Okay, so our fan is not spinning. So now two things we need to worry about. Number one, it's let's just connect. Where's the shell of the machine? So let us connect the battery and then connect the charger. Why this was not up? This was supposed to be up. Especially for this purpose now, it's easy to no, not to put it board. Not only that, I I, I can easily connect the battery to the board without having to sit the board in. You understand? Because I don't want to sit the board in. I just want to connect the battery. Okay. Let me see what I get. Okay. So let me now see if I get trackpad feedback. And then see if I get trackpad feedback. So the A15 to 2015, it just that the fan doesn't spin unless the machine it's super hot. But this is the 15 inches are different. Okay, we're not in SO state. So two things that we have to. So number one, our SMC, even though it's maybe we may have at some level SMC communication, okay, we still may have a problem with our SMC. Now let's just see what we have on our PP3 report, PP bus. Let's see what we have on our PP bus. See what we have on our PP bus. 12.57, that's fine. That's the ISL is doing its job. Let's see what we have our PP3 before two. 4.3, it's not okay. That is, yeah, that is too high. So what we want to do, the only reason why we have 4.3 is going to be that our ISMCs, it's working funny. So the, the first thing we want to do is we want to remove our ISMC and then see what we have on, let's see what we have on our PP3 before two. Because that line should be 3.4 volt, not 4 point. We don't need it to be boosted. Okay, SMC it's out. Now let's see what is it that we have on our PP342. As you know, whether the SMC is present on our PP342 will be present. So let's see what we have on our PP342. Oh, by the way, with SMC out, there will be no LED. PPDC in, let's see. Yeah, so we see obviously because there is SMT is not there, then PP342. It's a problem. Yeah. So
Test it before you say that you get the right.
yeah, so let's remove our ISO because
Okay, so this is my card. You have that I'm signing. So wherever you give it so, there's 10% discount on your thing.
so let's see what we have and no how you are reading anyway.
And also, please give us a review on Google, YouTube. YouTube also you can. Yeah, yeah, I'll send you.
Okay, and then PP342. Something funny is happening here.
Yeah, yes, please.
What's up?
Negative key. The guy, he took the key out of the card. Now we are calling him, that's the pick up. And the visitation is at 3 o'clock up to 4.
Yeah,
Keep calling, please, please.
Fly. You go.
No, he's not picking up a call.
Yeah, but you got a mobile now. You mobile now. Fly. Say hello to the boy.
Fine. Yeah.
The okay, so the machine is something funny is happening because PP342 it's giving us uh yeah 4 point something bro 4.9. Okay, so okay, let me just confirm something. 4.5 volt from 3 point.
What? Yeah, right. So 4.9, 4.9.
Okay, let's see. Okay, yeah, what's happening? Why are you giving us 4.5 volts? It's way too high. Okay, let's check that
You have
again.
a business card, right?
Myself,
Yes.
I don't have business cards no more. All my cards are finished. We can speak to that lady to help us out.
Yeah, that's what I was just thinking.
Let's see. Okay.
4.4.
Okay, so what we want to do is Let's check out the regulator.
Heat cannot affect the voltage of the multimeter, can it?
The multimeter.
Yeah, the heat cannot affect the voltage. Can
We
explain
just
to you.
confirm the multimeter with another board.
Like he was trying to explain that if the body is heat,
Yeah.
if we use a multimeter or the body is warm,
Warm.
is it not going to affect
Yes,
The reading on
yes,
voltage
yes.
its way, right?
Sometimes yes.
Yeah.
Okay. Now we'll have to come back to that, but before let's put back our SMC as well as our ISO. Okay. So okay. Give it a bit of time to cool off. You have any questions, Peter? Peter, is it not yet? Hmm. But also the the funny thing about understanding is it develops. Sometimes you might think, I think I understand it, but you actually understood it wrongly. But as time progresses, you be like, oh, this is actually what I. Yeah,
So
but
yeah, even from now I can say I can't say that I have a few 100%, but most of the things when you used to explain, I was like, where is he right now? I get lost. Like we are explaining something on a subject. I feel like I'm in the subject with you, and I end up like I'm lost. But I still feel like I am still with you. But right now, this is advanced. Like the what we are repairing right now. At least I have a hint of what exactly we are up to. Like right now, we are working on SNC. We are getting like 4.49 volts instead of getting 3.42, which is I'm getting it better than how I used to understand when we started to make the
And
lessons.
it's a gradual process. Over time, it's all going to click in place.
So I have a big feeling that in 2 3 months I will
Peter.
have some humor in me to know exactly what we.
2 3 months. It's not that simple. Eh?
It's true.
Also, sometimes there's another type of knowledge which is false know-how. Uh, because you've seen 1 to 10, then you believe from 10 to 100 should be the same thing. There's no need for me to worry about 11, 12. No, I've seen 1 to 10, so the rest should be the same thing. No, it's still not like that. You still, especially when it comes to repairs, you have to know exactly what you're doing. Otherwise, you just want to go like that. Nah, there's so much mistakes, bruh. You make so much mistakes, and the funny thing about it is you will enjoy it as you continue making the mistake because you feel like you always blame the machine. Hey, this one the PCH is dead. This one is dead. That is dead, bruh. All of the machines that come to you, PCH are dead. Yes, bruh. Clients are the problem. So you just have to make sure you know how to. Proper diagnosis is the key. You don't know how to do proper assessment. You keep changing power management chip.
It doesn't work.
No, man. Sometimes you'll be very lucky, bruh. And then it works and you start making calls, sending out WhatsApp messages.
I never realized that, especially with phones, when people call power management chief, I would never replace the power management chief since I started using phones.
But
I've never. It's either it's a gift, maybe when you do a BGA chip, it's very changing, charging, I see the new twice. Maybe audio, I see like what I was doing now. But most of the time, it's skips. Mostly, that's what you change. But I can tell you, power management chip is a statement where people
everybody, yeah, everybody call you out. I said I have a friend. Whenever he calls me, I need power management chip. My friend, why do you always need power management chip? Tell me what is the state of the device. I know what is wrong with it.
power
You
management.
just need power management. I mean, even to you, how can everybody device just need power management? Like how? They fail in one particular way, in one particular order.
Is it?
Okay, so now the first thing we want to do is let us see what we have on. So what we have done is we've transferred the PP3P40 circuitry, the inductor as well as the regulator onto this board and the one here to the other one. We did confirm before we transferred that it's working. So let's now, I don't know if you understand what we did. So we transferred the PP340 regulator IC from here and the inductor that we confirmed was working here onto the other board. And then we transferred that of the other board here.
Okay.
So if the problem was the regulator or the inductor,
Then you get 4.4 from this board.
exactly. However, sometimes if the chip itself is what failed, sometimes the heat can give it a bit of which is it may just work temporarily, but afterwards it's gonna die again. So let's just see what we have on Okay, let's see. PBDC in. Yeah. PB342. Yeah. So which means our problem is not. It's neither the inductor or the regulator IC. Because if it was, then it should get we should get 4 point something volt here. So which means we have more work to do here. First and first, let's just be sure that our SMC was properly installed and our ISL was properly installed. Because right now we're not really worried about let's not worry about the PP342. We'll go back to that. But first and first, let's see how is our ISL performing. PP342 the SMC running, we should get charger indication. Okay. There's a slight delay. I don't know if you saw that. Slight delay between. Okay, let's see what we have on PB bus now. Okay, SM, the ISL is fine because you have PB bus. Because if the ISL was not fine, we would not have PB bus. Okay. And let's see PBTC in. What do we have there? Okay, that's good because PBTC in is giving us 24. Then PB3 P42, 4.5, 4.9, 4.4. Okay, so um, okay. So what we want to do is we want to shift our focus to this section of the board. But before that, let's see what we have on our source rail. Source rail is going to be what will feed our SPI ROM chip, which is our BIOS chip. Let's see what we have on our source rail. Flip it to the other side. Source U6100. So pin 3, pin 8 of UCC100. Let's see what we have there. We should have 3.3 volts there. Let's confirm if that's the case. Mm-hmm. So we have a 0 volt. So we have a more pressing issue than. Okay. Let's just confirm something again. Hmm. This is not. Let me see. What board is this? 00138. Yeah. Okay. Let's check our source. 5 volt is present. Hmm. Okay. Hmm. Okay. So let's see if we have any component on the board that is heating up. The next thing we want to do is we want to use our diode measurement to check out the circuitry of PP342. Let's see what difference we have in measurement. 325, 325. Okay, let's just check that. Compare with the working board. 328. Yeah, that's pretty much fine. Okay, it's fine. 326, 326, 327, 326, 7. Okay, let's see what we have here. Okay. Excuse me. See if we have a short on our software. We don't have a short on our software. Let's go to this schematic. Eight zero 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 138. Let's go to E7100 and check source from there. E6100. So bias is SPRM check. Okay, so the SPRM. Now we are interested in this route here, AP3V3 underscore source. See where that is being generated because we clearly don't have it on the board. We have it. So we want to see where the chip itself, the route it's being generated. Uh, so, okay. So this is where it gets generated. Q8020. Let's go to Q8020. Q 8020. Okay, so this is the chip here Q8020. Uh, let's see how it's supposed to work. So we should have pin 4 and 7, 1, we should have 5 volts, 3.3 in S5, we should have 5 volt on the source, which is 4 and 7. Let's see, 4 and 7. Um, let's see, we should have 3.3 volt on there. Switch the voltage. Okay, we have 2.3 volt. And let's see how it's supposed to work. Let's see the enable signal. So PM sleep S PM sleep underscore source underscore L is supposed to be, so it's going to help to enable to create the enable. Otherwise, this is not going to open. So obviously at the drain we're expecting to have 3.3 volt. Let's see what we have on. Let's see. In 1 and 2 as the output, and then in 3. Let's see what we have on Q. It's 802. Q802. 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 Okay. S4 power enable PP3 source underscore EN. So let's see pin 5. What do we have on pin 5? Yeah, 0 volt. So we have 0 volt on pin 5. That's why our source is not present. Hmm. Okay. Source is not present also. It's not good. Yes, it's not present. It's here. U1100, which is our PCH. Yeah. Uh, um, let's see what we have. Hmm. Let's see what we have on. Okay, PPVRTC and that's PG3H. Let's see what we have on our clock. Okay, so our clock signal is 0 volts, so that's definitely power. So let's go to U1900. See why that is not working. U1900. Then we have pin 2. Let's see what we have on pin 2. As present. Uh, hmm, clock. We do not have the 3D. Uh, okay. Let's see if we have a short on that line. Okay, that's really bad. A short on the clock line. Okay. Okay. Let's just hope our PCH is fine. Before that, let's remove the caps on the line. And let's really hope that our PCH has not been affected. Let's really hope PCH has not been affected. That will be really bad. Really bad.
So what happens if it's affected? What is the story?
Uh, the Then you have to get another PCH. It's this board, getting another PCH for this board. Uh, it's a stretch. Uh,
Which means it has to be programmed or
the PCH doesn't just. It's not like a capacitor you just replace. It's. I never pray to have an issue that's PCH related. No, I don't like PCH jobs. Let's see. Let's see what we have. So we don't have our clock signal. And I'm just hoping that our problem is either one of the caps or U1900. I don't want our issue to be PCH. That would be nah. PCH? No. Okay, let's see.
what the caps going pushing you that side.
Ah,
Slowly
okay.
that side.
Now let's the final blow is let's remove the clock chip
The clock chip
itself.
itself.
It's been an hour, 20 minutes.
Okay. Practically, our issue, which came with someone, is resolved because
Now it's another issue
we
now.
yeah, because now PP342 is fine, PP342, PP bus is fine, SMC is fine. When it came SMC, PP342 had a short, but so my fear is just I just hope that that short So usually short has when you get a short on the board, there are two reactions if the device goes off immediately or afterwards.
Okay. So can you explain immediately what could be the consequences or maybe the issue? Not the consequences, like what does it lead to when it goes off immediately when there's a short?
So if you have, let's say the machine is on, it's an
Uh-huh.
SO, yeah?
Uh-huh.
And then you have, let's say component A suddenly gets a shock
Uh-huh.
and then it doesn't resist
All right.
and
Now
then
I
it goes off
it goes off.
immediately. That is fine because before there is any further damage.
It cuts
So
the power.
yeah,
It cuts the
so
damage.
is the same as the brain behind a fuse.
All right.
It's supposed to be the fuse is not supposed to hold forever.
Forever. When the current is it's something it can
It's
no longer
higher
hold,
than
then it breaks
yeah,
and then it stops the flow of
yes.
current like
Because if
immediately.
it doesn't, if it resists and
Then
not break,
then
the
you
damage will be caused after it. That is the issue.
yeah, now I understand.
So usually when you have an issue and then so that short that happened, if it's a chain type of short where this get affected and then the device off, you refuse to go off, you're still on.
And you're still on. Then it's pointing to somewhere where you
Yeah,
can
it just
where you
until you get. It's like when you have a damaged wire and then it breaks and then there is fire running through the wire. The easier you get it disconnect from the rest, the better.
yes.
Because once it's not, it's gonna make sure it
It's gonna
goes
make
to
sure
the end.
now it makes sense.
So usually U1900 almost never go faulty. So the chances of it being U1900 is very slim, and the chances of being PCH is very high.
Now, the clock chip on these machines, but I've seen on 1298 sometimes
No, clock chip go bad, but for them to be the cause of a short is rare.
or now I
You
understand.
understand?
Now I
Clock chip go bad, but for you to have a short on the PPVRTC line and it's because of U1900, it's very rare.
understand.
So I am very much leaning to the PCH. That's where I'm leaning to. But ish. Ah,
And none of those resistors is linked to ground at all.
link to?
To ground.
Nah, they don't. They're all to PCH. Yeah, nah. Ish. This is
So what creates the PPVRTC?
U1900.
Well, it's created by you like
Just check on it.
the ground.
Yeah. Oh, it's a what happened to this ball? And why did the PCH have to just die like that?
So it's a PCH.
Yeah,
So did you take off U1900 already or
yeah. That's what I'm telling you. That U1900 it's very rare for it to be the cause of the short. It's very rare. Yeah, I love
So under the circumstances that you need to replace the PCH, what stages do you need to follow?
I just need to reprogram it. So I just need to reprogram the BIOS.
Or the bias? Okay.
Mm, this board here, we only have this here, and I don't even know what the issue was. But this is bad.
And that thing is so big because then this machine is big as well.
What? How would the PCH go bad? SMC died and PCH died. Eh, okay. Uh, so at other IP to PCH. Yeah, SMC is doing just fine. SMC is flexing. Yeah.
4.5.
Yeah.
How is it feeding 4.5?
So
4.5 is your
PP3 P42
Oh,
instead of 3 point.
oh, oh.
Uh,
So do you think if you replace the PCH without finding why it run out, it's a good idea? Or you have to find out why as well?
no, that's not even no. So it's so what most likely happened on the board was a chain reactional type of failure,
Okay.
and then that's why in a situation like that it would have been great if the machine went off as soon as possible, like immediately happened, just died.
All right.
But if it still holds, it's not good. I need to confirm the state of this PCH here. It's just a shame. Uh, okay, guys. So first and first, we need to get a working PCH, and then we can return to this repair. I'll see you guys after we find a working PCH.